Okay, so we will be looking at the introduction to calculus, and which I will later combine with the topic which is called the functions. I will marry the two topics, but I first want to look at the introduction to calculus. The introduction to calculus. Now, this will deal with two parts, which is the differentiation and the integration. These are the two parts that we're going to deal with. And differentiation, we'll learn how to differentiate. Then later we shall look at the application of the differentiation linked to functions. Then after that, we have to look at integration and how that is linked to functions. How can you apply, rather I'll call it the application of integration on functions. How can we apply integration on functions? So there are very few things that I want to bring to your attention where functions are concerned. Now, when you're given a function written as y is equal to x raised to power m and then plus c, I've just given a general function. I've given that function, which is an equation, which is x is raised to power m and then plus c. Now I have to make you understand that this a is a function. Oh, sorry, this a is a coefficient. If you don't want to write it in that way, allow me to write an original equation, which will be y is equal to 4x raised to power 2 and then plus 3. This was a general function. This is an example where a is representing a number which is 4, and then x is a variable. 2 is m is representing a 2, and then plus c is just a number without x variable. Now let's give names to these aspects that are in the equation. This is a very, very important part. Once you understand this, even as we get to integrate, as we get to differentiate, this is what will be helping us to have it done. So this y here is just a variable. This is just a y variable. This is just a variable. Y is just a variable. Y is just a variable. Oh no, right. Y is just a variable. Therefore, here the number that is written before x variable is the coefficient. This x here is also a variable, x variable. And this 2 here, which is being represented by m, this is a power, or you can call it exponent. C, which is being represented by 3, that number which does not have a variable is called a constant. That is the introduction that we're going to have. So y is a variable, y variable. Then a, in our general equation, a is standing in for a coefficient. X is an x variable, and then m, the one written on top of the variable, is called a power, or also called the exponent. While that number which is the standalone, that number which is written alone, is called a constant. So that is the first thing that you have to know. A variable, two variables, x and y. Then you have a coefficient, a number written before an x variable. Then that number which is written on top of variable is called the power or exponent, while that number which is written alone is called a constant. Now, having looked at that, maybe it is very important to look at some general or some common functions. Yeah, I will have the approach in that way. Let's try and look at the general or common functions. What are the common functions? And these functions that I'm about to write are a little bit confusing if you don't really understand the indices. Okay, if you don't really understand the indices, it may be a bit difficult for you to get familiar with them. So the common functions, or we can also relate this to indices. Number one, when you have a function written as y is equal to 4, according to what I'm from writing, the 4 here, which is alone, is a constant because it does not have the variable, an x variable. But in the actual sense, this constant here has x variable, except that that x variable has the power which is 0. So this equation can also be written as y is equal to 4x raised to power 0. It's the same thing. Why didn't we include it here? Because according to the laws of the indices, anything, any number or any variable raised to power 1, or any number or any variable raised to power 0 gives 1. So when you have x, when you have x raised to power 0, that is as good as having 1. Then when that one is multiplied with a constant x or a constant 4, it brings us back to 4. Yes, Molly.
Can you please explain that part again? I got confused.
What I'm saying is when you have an equation y is equal to 4, 4 is a constant because it does not have a variable. But in the actual sense, this 4 or this equation rather can also be written in this way. How and why? According to indices, any number or any letter raised to power 0, it gives us 1. So in short, where we have 4x x power 0, it's as good as having 4 times 1. It just gives us 4. Because 0 raised to power 1.
So, sir, I have a question.
Yes.
So, power 0 can even turn a variable into a constant?
What I'm trying to tell you is, any number, according to indices, any number, the number can be 4, the number can be 8, the letter can be m, the letter can be 0.
I'm not saying, yeah, letters. Even letters can be turned into a number with the power 0.
That's what I'm telling you, yes.
Okay.
Whether it is a number or it is a letter, any letter or any number raised to power 0, they will give us 1. So when you have that, you should bear it in mind that this was multiplied to x raised to power 0, which gave 1, and then that is not included. This is what you need to know. That is the first thing. So the first thing is when you have a constant like that, I'm giving you this insight because during the integration and during the differentiation, when you have a constant, at some point you see an x appearing. You should know where the x is coming from. You should know that when you have it like that, it's the x which is there, but it's raised to power 1. Get that? That's one. Number two, according to the laws of instance, when you have y is equal to 1 over x raised to power 2, this can also be written as y is equal to x raised to power -2. It was written y over x. It is because the power was negative. So in China, making it positive, that's why there was needed to put 1 over something. That is one thing also you need to know. Because this is the part which is a bit confusing when it comes to integration and when it comes to differentiation. Now, if these are common functions or if these are common equations, now when you are told to integrate, what are we supposed to do? Oh, sorry, when you're told to differentiate, before we go to integration, when you're told to differentiate, what are we supposed to do? Now, look at any of this equation that we have. Well, maybe let me give you one, which is y is equal to 4x squared, where this is a coefficient and that is the power. Now, we can see that this equation has got two variables. We have got y variable. We also have x variable. Now, when you're told to differentiate, what are you supposed to do? We have to look at how the variables are changing. We're just talking about the changing of variables. Changing of variables. Which variables are the variables are y and the x? How are they changing? So we can say we are looking at the change. This is, let me not use these, the delta different symbols. So we're looking at the change in y with respect. We say change in y over change in x. The change in y over change in x. And this can also be written as dy over dx. I'm just explaining. You're going to understand it better when we look at the example. So when you're given a function like that, then they ask you to differentiate. When they ask you to differentiate, what are you supposed to do? You have to look at how the variables are changing, the changing variables, how y is changing with respect to x. How are these two changing? Now, what are you supposed to do for you to see how these two variables are changing? That's where our mathematics starts today. When they ask you to differentiate, they're asking you to look at how are these two variables changing, y and x. How are they changing? Because in this equation, I've got two variables. Now, how are the two changing? How is y changing with respect to x? How are they changing? Which will also represent as the dy over dx. So that is where our mathematics starts from today. So, whenever you are given a function, then you are asked to differentiate. You have to find the variables, the y and the x. Then in that equation, you should be able to tell the coefficients. You should be able to tell the powers, because that is how you look at how y and x changes. So So we're going to look at examples. Differentiate each of the following. How are you supposed to differentiate? Which one? So I have few examples. Number one, y is equal to x power. Now, when you are told to see how, you're trying to compare how y is changing and how x is changing. Or maybe before I get to this, let me give the general, let me first give the general statement. When you're given a function as y is equal to ax raised to power m, if you want to differentiate, which you say dy, the change in y over the change in x, all you have to do is look at the coefficient. Our coefficient is a and our power is m. You have to multiply the two. So you multiply the power and the coefficient. So we're going to have our coefficient, which is a, multiply the multiplication, then use the dot, a multiplied by the power, which is m. After you are done, you bring the variable, then to the power you subtract 1. That's how you differentiate.
Sir, please explain again.
Elders, let me call you. I'm having a class. Okay. What I'm saying is this: whenever you are given a function like this is a general function. The general function has got the coefficient, has got the variable, has got the power. Now, when they ask you to differentiate, find the change in y over the change in x. What are you supposed to do? Get the coefficient, multiply with the power. Our coefficient is a, so a multiplied by m, a times m. We are done with the multiplication. You write the variable the way it is, and then from the power, you subtract the 1. That is a general way. So now coming to the examples, example A, we are saying y is equal to x raised to power 3. Now, when you have that, you know that the coefficient here is 1. I should have wrote it on the general equation. The coefficient here is 1.
Sorry.
Yes.
Over there, is that a times mx or a times m?
A times m. A times m, x, m minus 1. So when you have this, you know that this is a y variable, this is the x variable, the power is 3. The coefficient is 1. So now finding the change in y over the change in x, what you're supposed to do is, what is the coefficient here? The coefficient is 1. So 1 times z, what is the power? The power is 3. A times m. Then you bring the variable x. What is the power? Our power is 3. Then you subtract 1. And how is it going to be? 1 times 3 will give us 3x, and then 3 times 3, we subtract the 1, we remain with 2. So our dy dx is 3x raised to power 2. And that's how we get to have it done. That is number 1. Number 2, we are saying we have y is equal to 2x squared plus 3x plus 3x. How are we supposed to differentiate that? Now in here, we have got 2 parts. There's this part here and that part. So the same thing we did to this x power 3, we're going to do it here, plus we also do it to that other one. So what do we do? So the change in y over the change in x, dy dx, will be, so we're going to multiply. What is our power? Our coefficient is 2 times, what is our power? Our power is 2. Then we write x. We write the power, then we subtract a 1. The same thing we have done here, we have a plus. We are also going to do it for this. We have a 3 multiplied by, that x has got the power which is 1, but when the power is 1, you don't write it. So we're going to multiply 3 times the power which is 1, then x, then we're going to sub our power, we know that it's 1, we subtract a 1. Once we do that, we are going to have dy over dx, which will be equal to 2 times 2 gets us 4. We have x, 2 minus 1, which is 1, but when the power is 1, you don't write it, just like when the coefficient is 1, you don't write it. We have a plus here, 3 times 1, which is 3. 1 times 1, oh, sorry, 1 minus 1 is 0. So x raised to power 0. And remember what I said earlier, that when x is raised to power 0, it's as good as having 1. So 1 times 3 just gets us 3. That is the answer. Okay, now we go to number 3. We go to number 3. We are differentiating each of the equations that we have. So we go to the third one, which is D. The equation is y is equal to 4x power 3 plus 9. So in here, we have a full package. Coefficient, variable, power, constant. Now, I have to bring this to your attention that when it is written like that, when it is written like that, it means you have got x raised to power 0. If you remember what I said. If you remember what I said, it means you have that. Now, what are you supposed to do? The same thing we are from doing to the previous equation, that's the same thing we're going to do. So we say the change in y over the change in x. We multiply the coefficient and the power, but I'm not going to write because we have done this for 2 or more times. So I'm just going to multiply. So 4 times 3 will get us 12x. Then the power, we're going to subtract a 1, and that will give us a 2. That's the simplest way, if you have gotten used to this. So you multiply power and the coefficient and the power. So 3 times 4 gets us 12. Then when you subtract the 1 here, you're going to remain with a 2. Plus. Now 0 times 9, so the coefficient and the power. So as 9 times 0, it's going to give us 0. Then when you subtract a 1 from a 0, so you say minus 1, we are going to have the power which is negative 1. But for as long as the number that we're going to have after multiplying, let me show you what I mean. So 9 times 0 will give us 0, and then x from the 0 subtract a 1, we're going to have -1. But when you multiply 0 and whatever the number is, you still give us 0. So this part disappears. Because even if you say +0, it's not going to change anything. Therefore, the dy dx is equal to 12x raised to the power 2. In short, when you have a constant, dy dx of a constant gives us a 0. You were saying something?
Can you explain again on that part?
This part?
That it's just going to be 12.
Here?
Yeah.
Okay.
Yeah. Which is going to
okay,
be
maybe let me not
12x to the power 2.
let me not use the shortest cut. So the same thing that we did, you multiply the coefficient in the power. So we're going to have 4 times 3, then x.
Yeah, I already know how you got there. I want to know how x and 1 isn't going to be there.
Here?
Yeah.
About
On 9x.
Okay, so this is the interpretation comes here, and then plus. So I'm going to say 9 times 0, and then x, the 0 minus 1. Do you know where the x raised to power 0 is coming from? It's something that I told you on the general equations.
Yeah.
Okay, then we're going to say 4 times 3 gets us 12. When you subtract the 1 from 3, gives us x raised to power 2 plus. Now, when you multiply 9 and the 0, it gets us a 0. Okay, it gives us a 0. So we're going to have a 0 here multiplied by. Now, when you subtract 1 from 0, we're going to have x raised to power -1. But now, because we are multiplying here, we are multiplying n number multiplied by 0. It gives us a 0. So when you multiply this part, it is going to give us a 0. But even if we add the 0 to this existing number, the number is not going to change because we're adding nothing. That's why I just decided to remove it. Okay. Is that understood?
Yes.
Okay.
Yes.
We go to this, the fourth one, second last. The fourth one, second last. So the fifth one, right? Oh no, it's supposed to be the fourth one, which is D now. Will be y is equal to 2x raised to power 4 minus x and raised to power -3. That is sorry, supposed to be E, this one. So how do you deal with such? How do you deal with such? The concept is just the same. So we say dy over dx, it's 2 times the power, which is 4, x the power, we subtract 1. I believe we have no issues with that. Right? Minus the coefficient here, it's 1. The coefficient here is 1. That's why they did not write it. So it is 1 times the power, which is -3. And then you say x, -3 from the power, we subtract a 1. So we are going to say that 2 times 4 gives us 8x. A 1 from 4 gets us 3. Now we are multiplying a negative and a negative will give us plus 3. Negative minus negative, we are going to the negative, we are adding on the same side. Yeah, we are adding on the same side. So negative, we're going to have x raised to power -4. But because the power is negative, if you want, you can also write that is x power 3 plus 3 over x power 4 by just changing the power to be written as a positive number. But if you want to leave it like that, leave it like that. It is just the same. Yeah.
Yes.
The last one. The last one. Let's look at the last one. The last one is so if we have y is equal to x squared minus minus 2x raised to power 4. Now look at that. But we understand very well that this can also be written as y is equal to x power 2 minus 2x raised to power 4. By converting that which has the positive, because it said number over, because of the over, we know that the power was negative. That's what I have decided it to take it that way. So once you have this, it becomes easier for you and I to do the dy over dx, so that we know that the coefficient here is 1. So 1 times 2 will get us 2x. Then when you subtract a 1 from a 2, we're going to have a power which is 1. But when the power is 1, you don't write it. Then what are we going to have here? We have a negative 2, which is being multiplied with negative 4. So negative 2 times negative 4 will give us positive 8x. Now, from that negative power, when you subtract a 1, we are going to have the power increasing by 1, which is minus 5. So that's the answer. So the most important thing is you start the function that is given. Start the function that is given. How is the coefficient? How is the power? Is it positive? Is it negative? Then you start multiplying the power and the coefficient, and then from the power subtract the 1. Just even if they were supposed to be 10, you do the same to all those 10 entities. Are we okay?
Yes.
Yeah.
So now let me give you the general tips where differentiation is concerned. Let me give you the general tips. So the general tips now. If the function given is y is equal to a constant 4, or any number, dy over dx of a constant gives us a 0. 2, when you have y is equal to x negative 2, dy over dx, when the power is negative, when you are differentiating, the power increases or the power reduces by 1. We have a 2 which is bigger than a 3, so the power has to reduce by 1. And when you have the third one, y is
Sir,
yes.
does it reduce or increase by 1? Does it reduce or increase by 1?
When the power is negative, it has to reduce. because -2 is bigger than -3. So this one is smaller than this,
Oh,
according to the number line.
okay.
Yeah.
Okay.
Then when you have a single letter like that, dy of y is equal to x. So the dy over dx equal to 1. These are the generatives that we have to know. Then fourth one, if y is equal to x squared, then the dy over dx will be 2x. And the last one, the fifth one, so given y is equal to 4x, the dy over dx will be equal to 4. So where you have this 4 can be any number, even if it is 10, to give you a 0. Then here, this one is constant, but if here the power was -3, it will be -4. If it was -5, it will be -6. Then here, if the power is 10, y is equal to 10, y is equal to x raised to power 10, it will be 10x. If it is x raised to power 5, it will be, sorry, if it is 10 here, if it is 10, x raised to power 10, it will be 10x raised to power 9, because the power will reduce by 1. Here the power reduced by 1, we have the power of 1, that's why we didn't write it. Then here, if no matter how big the number is, that is going to be the number, provided the power is 1. So if the number here was 12, y is equal to 12x, dy dx just going to be 12. So that is the introduction to calculus that we're going to look at today. Any questions?
No.
Any question?
No, sir.
Muka? You okay?